Welcome to our course, Data Science Project. And in this part of our course, we're going to continue our project, which is all about election vulnerability index. So in our past lesson, we actually talked about some data processing and some data preparation of this data for us to be able to move on to the next part of our project, and that is really the modeling phase. Let's go to this part. Basically, what we're going to do here is that we're going to use the k-means clustering for us to be able to identify the different clusters or groups of countries which belong to certain groups sharing similar characteristics. So later on, we'll be identifying who these or what these countries are and what are their profiles. So first of all, because we have actually identified the correlation of the different features that we have. So by this time, we're going to do some further analysis, and that is by eliminating some of these features because of course we could not use all of them. So basically we're going to set the threshold, and in our case we have a 0.8. So which means to say when the threshold is above this one, then what we will do is we're going to drop these features if there are more features which are multicolorated. Or what this code does is that for, of course, for every column, we first iterate by identifying their threshold or their correlation value. And once they are identified, what we will do is we drop them. So what does this particular line mean? So this basically excludes the first variable and those variables which are highly correlated based on our threshold, which is actually here in our case because we made a list and the second entries to the last entries will be removed from the features to be used for the modeling. Okay, so let's execute this one. All right, this one is done. So just to show what these variables are, we first have to print this. So let's see what this list of correlated values or correlated features. Okay, so we have these features which are correlated. So as you can see, we have this vulnerability to internet disruption. So this is just one. And also we have this quality of most recent executive elections. We have this quality most legislative elections. So what it does here is that for this one, because we do have a lot of list for a certain list, of course, we are just going to choose the first one. So this is why we have this line of code that will tell you that we just retain the first entry for this particular list. So basically, we just would like to identify the variance inflation factor. This is actually also very important for us to also identify which ones are highly correlated. This is just a reinforcement of what we do in this case. So basically, the values would depend on the company standard, but statistically speaking, when we say VAF, those that have a value of 4 and above, they would be assumed to be highly correlated. But of course, it would still be dependent on our practice and our agreement as far as the company is concerned. Now, what we will do here is we will be doing more processing. So the name here is using PCA, but actually for the final implementation, I don't use PCA because in the first place, this is not applicable as PCA is only applicable to cases wherein we do have a lot of features, more features in comparison to the number of rows. So we first copy the DF new. The DF new is actually the product of the processing that we did before. Let's execute this one. So that this one, DF new that columns, this is just to see to it that the characters in the names or features are in their lower cases, just to of course make your processing easier, because sometimes the mistake would lie on the kind of case. Is it the lower case? Is it an uppercase that we use for our processing, which sometimes would entail a lot of time because we would like to find where we get some mistakes. Okay, so let's see what we have in here. So now it's good to go. All of these feature names are in the lowercase. So let's find the information. All right, so basically this is good. We don't have any null values. So this time, we're going to drop these columns which are not actually important, and these are the election month, the year, the month, On total, the digital sphere, human rights, electoral system, and political participation, digital sphere, and total. These are just actually the sum total of their respective categories. This time, we also want to set the country or territory and region as our index. So let's execute this. All right. And now we would like to convert a nominal category columns to number because of course when we are dealing with machine learning, we actually process numbers and not words or letters. Then what we do here is we get a dummy variables for all of these different numeric categorical columns. So that's why we use the PD dot get dummies. Then let's see what we have in here. Now we have country, territory, or regions are we index. Then we have these different columns or features and the corresponding numerical values. So we are now ready to apply our k-means clustering. So we instantiate first our model having the n clusters equals to 4. And of course, we will change this one later once we determine the optimal value of clusters to be used. The maximum iteration would be 1000 and the random state would be 0. Now, let's fit our data to this one. All right, so this is done. Now we would like to identify the different clusters for each particular data point. Oops, what's wrong? Okay, so that is executed. We would like to set the range for the K, and then we also would like to set or iterate over the cluster size options. So what we get here is actually the scores only. So we want to identify in as much as possible the scores for each label. The range of the clusters that we've set here is only 1, 2, 3, 4, 5, 6, but of course you can increase the number of clusters. But of course, it's actually very logical to increase the size. It's because we have just set this one into 4 only. So, but it's up to you. But I suggest do not increase because you will just be wasting your time. So this is actually a lot of computation, especially in cases where we do have a lot of data points. But in our case, we only have 45, so the computation does not entail much time. And of course, the computing power of our machine. So we have here the results. So we have 138, and we can actually see the drop. There's a bigger drop from 1 to 2 and also from 2 to 3. And the minimal drop we can see from 3 to 4, 4 to 5, and 6. So having this one, identifying the drop or the gap between each scores here, the inertia. This is actually what we call the inertia. Can sometimes be very confusing. What we want to have is just we want to see the drop, the scores, the optimal value at one glance, and that is by using the visualization. So now we have this in elbow method, and what we can see is that we have 1, 2, and 3. So we have 3 optimal number of clusters. So basically, we would like to reset the index, and then let's have this one, and then we have this. So we just would like to identify the labels that can be found for, I mean, what label each country belongs. So for example, if Albania belongs to label number 3, Angola is 1, and so on. Now we will want to reset the index, and let's see what is in here. All right. We have reset the index as we had before. We have this country and territory and region. So we reset the index because we would like to have more drill down of our data, the results of our analysis. All right. So let's have this one. Let's count. So for label 1, we have 18. 3, we have 13. 0, we have 9. 2, we have 7. Now let's see the BIC score. BICS. This one actually takes some time. The computation for this is actually more intensive in comparison to just compute for the inertia score. Just relax and we will get there. Now it's done. So let's also implement the elbow method for this one. So we have 3. 4 can be considered also. So better. Okay, this is just actually in the inverse form of this one. So for the BIC scores, it would tell us 4, but for the inertia score, it tells us we have only 3 clusters. So let's have this, the silhouette. And even our silhouette score would tell us that we have 4 clusters. Okay, so we have 4 clusters. Now we want to first get the unique values in the label column, and we want to iterate over unique labels and compute statistical summary for each group. So this is what I've said a while ago, that what we want to get is the profile of each cluster. So let's see what we have in here. So this is the profile for cluster 3. This is the point. These are the points, or of course the count. And then we also have the profile for group number 0, cluster 0, cluster 2, and so on. So you can actually make comparisons. Now let's have the cluster visualization of the data points for each cluster. So we have 1, 2, 3, and then we have the 4 clusters. So this is how we see them when we use the scatter plot, or what group the Philippines belongs to. Okay, the Philippines belongs to cluster number 3, and okay, this is also, yeah, same. Let's go back to the original one, the DF. And let's see what these countries belongs to cluster number 3. All right, we have these different countries. So we have the Albania, Burkina Faso, Colombia, and so on. Do you want to know more about this channel? Just click these cards. We do have a lot of free data science courses for free, like Machine Learning Essentials, Deep Learning Mathematics, and a lot more. Here, you can always learn an upskill for free.